Can you see if I shut the lights off? You want them off? It gives the illusion that it's cooler, right? But maybe it really is. Who knows? Okay. So today you can tell by the title that we are simplifying rational expressions.
Ugh. Sorry.
No, I'm with you.
All right, I'm ready. Let's do this.
All right, so there's really only two steps. We are going to simplify any of these rational expressions, you are going to first factor numerator and denominator separately. Step two, you're going to cancel or reduce whatever you can. That's literally it. The most common mistake is that students do these two steps out of order. You have to just look. So if we're going to look at number one, I'm going to look at just the numerator all by itself. 9a, there's nothing to factor there. Okay, that's fine. So I leave that alone. But in the denominator, so if I cover up the numerator, I'm not even looking at it. I'm only looking at that denominator. 15a squared plus 3a. What can you factor out of that? 3a. So let's take out a 3a and I'm left with 5a plus 1, right? I like to kind of cross this out just so I know that I've done that. So step one is done. I factored the numerator and denominator separately. And then step two says cancel or reduce anything that's possible. So do you see anything that we could reduce with each other? Here's the thing. 5a plus 1. Let's just talk about that binomial. I can't touch anything in that binomial unless I had the exact same binomial up top. So binomials, you can only cancel the entire binomial with an entire binomial that matches, right? So I'm not going to touch this 5a plus 1 at all. But look, I have 9 over 3 and I have a over a. Can't I reduce and cancel those? Of course I can. If I reduce 9 over 3, what's that become? Just like a normal fraction. What's 9 over 3? Just 3, right? So I'm going to reduce that, becomes a 3. That 3 goes away, it becomes a 1, but if it's just a 1, I really don't need it. And then what happens with these a's? They just cancel. They become 1s, but again, I don't need them because I'm just multiplying by 1. So my final answer is literally just 3 over 5a plus 1. It is that easy as long as you go in that order. Here's the mistake that some kids make on something like number 2, let's say. They come in here and they're like, oh, look, k over k, let's just cancel those out. That is so wrong, I can't tell you. Don't you touch that. You can't do that at all. That numerator is a k plus 1. That's a binomial. You can't touch it unless you have an identical binomial downstairs to cancel it with. Let's see if we do. Step 1 says to factor. There's nothing to factor in the numerator, but does the denominator factor? Sure, factors of 3 that add to be 4. Bless you. A plus 1 and a plus 3, aren't they? And now, oh my gosh, I do have a binomial that matches. So I can reduce the entire k plus 1 with this entire k plus 1. Bless you. So what's my answer? Is my answer just k plus 3? No! 1 over k plus 3. Because k plus 3 is in the denominator. So I need to make sure that it stays there. Okay, you try number 3. Got an answer? What does my top factor into? Or what can you take out, I should say? 10x. So we'll take out 10x and I'll be left with x minus 1, right? Okay, so that one's done. Downstairs, there's nothing to, oh, I hate when I'm in the glare. Hold on. There we go. Downstairs, there's nothing to factor. It's just an 8x. So is there anything that I could reduce? Let's go piece by piece. Can I reduce 10 over 8? Of course you can, right? Just like a normal fraction. So let's reduce them by 2. So that would get me a 5 over 4. Right? Everybody agree? What happens with the x and the x? They cancel, right? So they're gone. And then what happens with this x minus 1? It's just going to stay. There's no other x minus 1 to cancel with it. So make sure that I leave it in parentheses x minus 1. There's my answer. Do you need to multiply this out? No, I don't care if you do. So if you left your answer like that, that's perfectly fine. If it happened to be multiple choice and you didn't see the answer like this, but you saw 5x minus 5, okay, they must have multiplied it out. But you don't have to. Usually we don't. We just leave it. Seems pretty easy. It is. Let's jump to a tougher one maybe. How about, well, let's go medium. Let's try 8. Remember, factor first. You almost want to pretend that the denominator doesn't even exist yet. Just factor your numerator, then you do the denominator, pretend the numerator doesn't exist. The last thing we're doing is we're canceling and reducing. You have to resist the temptation to come in and say, oh, look, x squared, I'm just going to cancel. You can't do that. You have to factor first, then cancel. Okay, you got an answer? All right, up top, what does that factor into? Yeah, x plus 6, x plus 6. All right, great, that one's done. Downstairs, what can I take out? 3x. And what do you know? I'm left with x plus 6. How cool. So now what can I do? I can I cancel all 3 of these? No! One of them. So 1x plus 6 cancels with 1x plus 6. Can I do anything else? No, you can't. I know you want to cancel those 2 x's. You can't do that. Why? Because that x is part of a binomial. The only way to cancel as a binomial is like we did here. It has to be an entire one with an entire one. You can't do pieces. So my answer just stays x plus 6 on top, 3x on the bottom. That's fully simplified. I cannot go any further than that. Are we feeling all right? Oh, you know what? Try 12. That's got a factoring pattern we haven't seen in a while before we get to the real tricky ones. You have an answer?
So it's n minus 5 over n minus 1.
That sounds right. I don't have the key in front of me, but look at my quick glance, that sounds right. So the question is up top, that n squared minus 25, does that factor? N squared minus 25, can you factor that? You bet you can. That's the difference of 2 perfect squares, my friends. You didn't forget about that, did you? Anytime you have perfect square, and it's a difference. doesn't it factor into n plus 5 and minus 5? Remember that? It's just plus minus, square root of each. Then downstairs, I'm like, oh, okay, I need factors of -5. That have to be a positive 4. Wouldn't that be an n plus 5 and an n minus 1? Right? Do you agree? Always okay? And now I look and I see, do I have anything that can cancel? Oh, yes, n plus 5s. Anything else? Nope, that's it. Is that what you said? Was that your answer?
Oh, yeah,
It was? Good job. You're done, by the way. You can't, oh, it drives me crazy when kids then try and go further and cancel these ends. You can't. Stop doing that. 2 steps and you're done. Okay, now it's been a real long time since we factored when a is not 1. Let's try 14. Do you even remember how? First, you should always see, is there just a common factor you can pull out of the whole thing? Sometimes you get lucky and then a isn't something other than 1 anymore, or something that's not 1. But here, I can't take out a 3. I can't take anything else. So too bad, so sad. So do you remember whatever method you used to factor when a was not 1? You might have done guess and check. You might have done slide and divide. You might have done factor by grouping. I don't care what your method is, but you have to have a method that you can use reliably. Because this whole chapter, you got to factor the heck out of things. So we got to make really, really sure that we're good at factoring. I'll refresh your memory on slide and divide. Well, I can do any of the ones that you want, but I'll show you my method after I give you a chance to try it. So let me stop talking so you can do that. Ooh, you get lucky on the denominator, don't you? I think you do. Okay, so the numerator, I got to factor this. So you know what? I'm actually going to go over here and do a little side work. So if you're going to do slide and divide, here is your super fast refresher course. You're going to multiply your first number times your last number. So that now becomes a squared plus 14a minus 147. Now you factor it like normal. So I'm looking for factors of negative 147 that have to be a positive 14. And I think I found them. I think it's a positive 21 and a negative 7. However, that's the slide part. Now you have to come in and do the divide part. So whatever you multiplied by in the beginning, so 3 in this case, I now need to divide both of these terms by that same number. 21 divided by 3 is just 7. So that's one of mine. And then this, I can't reduce 7 over 3. So remember how 3 snuck up in front and becomes 3a minus 7? Now, no matter how you did your factoring, whether you did guess and check, factor by grouping, it doesn't matter. We all should have ended up with these same 2. A plus 7 is one of them and 3a minus 7 is the other. Did you get those 2? just checking. Yep, okay. I wanted to make sure that I had it. All right, so there is that numerator factored. It becomes a plus 7 and 3a minus 7. In the denominator, we get a little bit luckier because I can factor out a 6. I can take a 6 out of the whole thing. And now my life is a little bit easier because now I have a quadratic where a is 1, right? That 6 is just, I'm done with it. I'm just going to pull it out, right? And now I'm just going to factor what's in here. So factors a -7 that have to be a +6. Wouldn't that be a +7 and a -1? And there it is. And now step 1 is finished. I have completely factored the numerator and the denominator. Now I can come in and see if anything cancels. And lo and behold, I do have something that cancels the a plus 7s. Does anything else cancel? No, you can't touch. I know you might feel like, oh, can I reduce this 3 and that 6? No, because that 3 is part of a binomial. Binomials are untouchables. All right, so then all I do is I write my answer. What's left in the numerator, 3a minus 7. What's left in the denominator, 6 times a minus 1. That's it. Oops, sorry. Does that make sense? Is everybody all right? I do just want to address very quickly, if you look back at the directions, it says simplify each and state the excluded values. So I'm not a big stickler on if you do this or not, but I do want you to know what that means in case you are, let's say you're taking the final and they ask you something like that. That just means what you always looking at the original, what number am I not allowed to get as an answer no matter what, because it would give me a 0 in the denominator. So for example, if you look at number 4, right, before I do anything, before I'm canceling anything, I say, oh, well, you know what? B could never equal -2, right? Because wouldn't that get me a 0 in the denominator? Right? You see that? So if I were asked what the excluded values were on this, excluded value here would be -2, because that would give me a negative or a 0 in the denominator. So what's my excluded value in number 6? What's that? On 6, you got one. What number would give me a 0 in the denominator? Joe? 2. So 2, I can't have, right? Because 2, if m ever equal 2, that would give me a 0 in the denominator, and I can't have that. So that is my excluded value. You can have more than one excluded value if you look at number 5 real quick. Basically, I'm taking that denominator and I'm setting it equal to 0. So I couldn't have, let's factor out a p. I'd have 3p plus 3. So p could not equal 0, and p could also not equal, what's that, -1? So this would have excluded values of 0 and -1. Because either one of those is going to get me a 0 in the denominator, and I can't have that. So that's what they mean by state the excluded values. I don't necessarily care if you do it for the rest of these. I just wanted you to see what it is. And so when you are asked, that's all they're asking about. Okay, but I would like you to try and finish. There's not that many left that we didn't do, is there? Try the ones we haven't done. Let me get the people that need to take the test next door so they can take the test, and then we'll go from there. Okay? Okay, so bless you. Stop this video real quick.